Okay, welcome back. This is Sebastian. Um, Today we'll be looking at the step-by-step guide, or will I call it the step-by-step guide for Kaplan-Meier analysis, the mathematical theory. Let me just quickly share my screen. Where is my board? Great. So we defined Km, that's the Kaplan-Meier estimator, as a non-parametric statistics used to estimate the survival function. All right, which represents the probability that an individual survives beyond a specified time. Now, before we go into that, let's try to define some variables here. So the first variable we are going to define will be event time. So this is the time at which an event occurred. It could be relapse or anything you want to work in. Then the next variable is number at risk. Number at risk, known as NI. So this number at risk is the number of individuals at risk just before time t, just before the event of time. All right, so the next one we are going to look at is the number of events. Delta or D. So this number of events is the number that occurs at time t. So remember, we are looking at it per time. Then the next variable we need to is called censoring. So censoring. So these are individuals, all right, who leave the study or they do not experience the event during the study period. So they are accounted for, but are not included in the number of events D. They are not included here. All right. After their last observation. So for step 2, which is to look at the survival function. So the KM estimator calculates the survival probability, as the product of the survival probability over discrete product of survival probability over discrete time where event occurs, where the event occurs with a risk, number of risk. So we've already defined what the D is, the DI is, which is the number of events. We've already defined the NI, which is the number at risk, and the event time T. So this formula indicates that the survival probability up to time T is the cumulative of the probability of surviving each time interval. Now, the step 3 is to organize your data. Organize your data. In organizing your data or to perform KM analysis, you need to organize your data as follows. 1 is the time or event of time. So list all the distinct times at which event occurs. 2 is the number at risk. So here you count the individuals at risk just before time. 3 is the number of events here. That is the D. So you count the number of events occurring at each time. Now for the censored observation, you see that the decremeter at the time of censoring do not include it in the number of events. So let me rephrase that. So sorry, let me say that again. For censored observation, this decremeter at the time of censoring do not include it in the number of events. So if we then want to compute, which is step 4, if we then want to compute the survival probability, we'll be looking at the probability of surviving interval, which is going to be, or the probability of surviving interval just before time, which will be 1 minus d over the number of risk. So this is the probability that no event occurs at time t. All right. 2, if we want to calculate the cumulative survival probability at t1 or ti, so what we are going to have will be, oosh, sorry, where's my cleaner? Yep. So what we are going to have at this point is going to be the time minus 1, okay, multiply by the survival probability interval or probability of survival interval. That is the whole of this. So we are going to have, okay, so for the first time of events, so if we want to look at the first time of events, that's T1, it's going to be 1 multiply by 1 minus, all right? Now in handling sensory, censoring occurs when individual exists. Sorry, when individual exits the study without experiencing the events. So for KM, the censored individuals contribute to the number at risk, all right, until their sensory time. Now, after their sensory time, they are removed from the risk pool, but they do not contribute to the number of events. That's the D. All right. So what this does is to ensure that the censored data is appropriately accounted for without without any form of bias within the survival estimates. That's what this does. So if we want to construct our Kaplan-Meier table or create a table summarizing the key calculators, so we are going to have, that is step 6. So we are going to have something like this. Already the time. Then we are going to have the number at risk. Then we are going to have the number of events. And we then look at the survival probability for interval. Then the cumulative probability. So this is how our table looks like. But if we want to plot the graph, so if we want to plot the Kaplan-Meier, the KM curve, so we try to create a step function. So plotting the cumulative survival probability, S of t, against time. So this will be in this form. Let's see. This is just a sketch. So You may just want to have the curve tip at each time t, and I'll then mark the on the curve at sensory times to indicate where individuals at what point the individuals were censored. All right. So let's try to build a data set around this and calculate it and see. So we are going to create event time. Oops, sorry. So we're going to create event time t to be 2, 4, right? 6. Now, at risk individuals, that is the NI, we are going to look at 10. At risk count 2, we are going to look at 9. At risk count 3, we are going to look at, let's say, 8. All right. So for the sensory individual, 1. So one individual censored at time t is equal to 5. Okay. Oosh. So let's then calculate the km calculation. So for s of t, that's s of time 2, which will be 1. All right. If we do this, we should have 0.9. Okay. So if we want to look at it as at s at 4, remember? Ooh, sorry. So for S, remember that the events of time that we have is 2, 4, 6. So for events of time 4, we're going to have 0.9, which we've got from the first event, multiply by the probability of survival. This will give us 0.8. Now for X of 6, we are going to have the 0.8 that we have here multiply by the probability. That is the survival probability, which is 1 minus, no. Hold on. Let's go back. So for time 4, for the time 4, for the probability of 4 of time 4, we're going to take the 0.9, okay, multiply by the survival interval. We multiply it by the survival interval. At this instance, because we've taken 1, it's going to be, the survival instance will be 1 minus 1 over 9. All right, which will definitely give us 0.8. So we made a mistake in the first instance. So if we look at the probability of at time 6, it's going to be the 0.8 multiplied by the survival probability, which is the formula of 1 minus the number of events divided by the individuals at risk. Okay, so in this instance, remember that the risk that we saw from, or we from our data set for N2 is 9. Then the risk for N3 is 8. So this is going to be 1 minus 1 over, sorry, not 1, so it's going to be 1 minus 2, because the number of events we are looking at here is 2. That is the number of events D3 is 2. 2 divided by 8, which this will give us 0.6. All right, so if we want to populate our table now, our Kaplan table, based on what we have, time, that's Ti, for 2, 4, 6 will be Yeah, for 246, then the number of risk, which we have 10, based on the data set we generated, and the number of events for this time interval, then the survival that we calculated, which is 1 minus the event over the number of risk, right, will be 0.9, well, 0.88. Then I think, what did we get here? Then 0.75. If we add it there, then the cumulative survival will then give us 0.9, 0.8, and 0.6. So the Kaplan-Meier estimator is a powerful tool for estimating and visualizing survival functions in the presence of censored data by combining the mathematical rigor with intuitive graphical representation, which will be seen next. And it also allows to explore and compare survival patterns across groups effectively. Thank you.